Hello everyone, welcome to this video. In this video we are going to look at an application of alternating group while we wanted to solve a disk sliding puzzle. So here let's see what is the puzzle first. So here you can see these 6 circles, correct, and one circle is empty. So the empty circle represents empty disk, while the others are representing the disks which are having some number between 1 to 6. So now what is the puzzle? We have to we can only slide the disk from the paths which are indicated and no other movement is allowed. So that means 3 cannot be flipped with 5 in this case. So this is the rule. Another thing is that we cannot lift or the disk, or we cannot jump them. So we just have to slide them from one position to other. So this is what is the rule. So using different sliding of this disk from starting from this position, can we reach at this particular arrangement of disk? So you could pause your video, think for the solution, and then resume watching. Okay, now I hope you have reached at the correct answer. If not, let's proceed further and see the answer. So we have let's start with this figure here. So we have this figure here. For this figure, what we can do, we can just shift this 3 to this empty space so that it could further be moved to this place, so that you will now shift this 4 to this place in place of 3, 5 to the place of 4, 6 to the place of 5, and 1 to the place of 6. So basically your 1 moves here, this 6 moves here, then 5 goes here, 4 goes here, and then this 3 moves here, right, overpassing this empty space like this. So this is the arrangement that we obtain in the first case, and you can represent this in terms of cycles like this, because you can start by any number. I have started from 3. So 3 in here goes to 1, 3 goes to 1, then 1 goes to the place of 6, 1 go to the place of 6, 6 go to the place of 5, right, 5 go to the place of 4. Okay, so after having this arrangement, next we obtain this arrangement. Next, what we can do, we can move on to another cycle. We can again shift all of them one place in the next direction, right? So this 3 would come here, 1 would come here, 6 would come here, 5 would come here, 4 would go there, right? This is what we are doing, and you can represent it in this permutation as I have just explained to you. After that, what we can do, we can keep this element, this element, this element as fixed, and we can rotate these elements in this manner. So that means we are shifting this 4 first here, and then we are shifting it further, right? Actually, what we can do, we can shift this 4 here, then this 2 here, then this 5 here, so that we have an empty space here, so that this 4 would now move to this place. So you can represent this in terms of permutation as 5 moving to 2, 2 moving to 4, and 4 moving to the place of 5, right? After this movement here, we will obtain 2 shifted to the place of 4, 4 shifted to the place of 5, and 5 shifted to the place of 2, right? This is what we obtain here in this figure. Now next, lastly, what we can do, we wanted to reach at this arrangement where we have 3 here, 5 here, 2 here, 1 here, 6 here, 4 here. Let's see how and where did we reach. So in this arrangement, we have 5 at its place, right? We have 1, not 1, not 6, not 4, not 3. So how we may obtain and reach here? If you shift all of them clockwise in this direction, then we'll be reaching at a final result. So let's go back and see this thing. So here 5, we do not need to change this 5, so let's keep it fixed. So we have to place this 3 here, this 1 here, this 6 here, 4 here, and ultimately this 2 would come to the space and then it will come to the place of 4. So this is what we are doing finally, and we are getting what was desired as the final answer. So you see, we require 5 steps in order to do that, and it's very easy. We have the required solutions while we perform different permutations here, right, of different cycles. So this is how easy and simple it is to use permutations here as solving a puzzle of this kind. So I hope you understood this application here. Well, that is it for this video. Thank you for watching.